morning, my dear students. In the last week, we have begun the new chapter, that is classification of elements and periodic properties. So here in the last class, I said you history, how the scientists begin the classification of element. The first person was who is that Doberina. He arranged a set of three elements, that is called as triad. Second one is Newland. He arranged the elements. Every element is having the similar properties to the first one. And the third one is Mendeleev. He arranged the elements on the basis of similarity properties. So elements which are having the same property, he given the main preference for the same property. No doubt these three fellows are arranged the elements in the increasing order of atomic mass. And set those elements on the basis of property. They are having the similar properties. So I said you the first table, periodic table, that is the set of elements, they are launched by the Mendeleev. So that is called as Mendeleev's periodic table. Hence the father of Mendeleev periodic table is Mendeleev itself. One thing. And there was a one statement, state the Mendeleev's periodic table. I said you the physical and chemical properties of the elements. The physical and chemical properties of the element are the periodic function of their atomic mass, means as the atomic mass increasing, the properties are repeating. Therefore physical and chemical, means generally the chemical properties together, both physical and chemical, they are having the periodic functions on the increasing order of their atomic masses. Why? Because here is the elements on the basis of atomic mass. So keep in your mind. So this was the main important point. In overall, from beginning, means the whole chapter of this one, the most important one is Octave's law, Newland's Octave's law. They will ask you for 1 mark. And second one is this, state the Mendeleev's periodic law. Second one, this is important. And in the last video, I asked you one question, that is, the Mendeleev kept some spaces vacant. So he said that how the elements after discovery, what will be their properties. Because of his gap, it is influenced us to determine two elements actually. I asked you which of those two elements. So very few were asked for the answers for that. So grateful for them because they are interested much. And here what are those two elements means? Mendeleev said aluminum and silicon. These are the two elements. Below the aluminum, below the silicon, he kept vacant. So he said that two elements still at the time of his discovery, those were didn't discovered, but he kept vacant, and he said the gap of space below the aluminum he called that as aluminum, and he kept vacant below the silicon, and he named that as silicon. Means below the aluminum, which is having the element, those elements are having the similar properties to the first one according to him. And he said that so those elements are similar to the physical and chemical properties, and below the silicon, those are having the similar properties. The element which is present below the silicon, he named that as silicon. So here, after his death and after long year, so we discovered that below the aluminium, gallium is present, that is Ga, gallium. Below the aluminium, silicon, germanium, Ge. So after his death or by his influence, it is possible to determine the two elements. What are those two elements? By his influence, we able to discover the two elements, that is below the aluminum and below the silicon. He named those as aluminum and silicon. The two elements are gallium, another one is germanium. So sometimes they will ask you. So keep in your mind the two elements which are discovered by the help of Mendeleev is nothing but those two elements are gallium and germanium. And here, no doubt that he also did the very greatest work, that is Mendeleev. But this theory also failed, as we have observed the previous also failed. So this is also failed. Why? Because in that time that we have discussed this failoverless on the basis of isotope. I would like to remind you. So you have studied this chapter. So up to what I have explained, these are completely on the basis of the 10th. So right now, next onwards, we are having the different path for PUC. So here we are seeing the main cause for failure in the Mendeleev is whichever you have studied it in the time, it's also the right thing only, it's not wrong. So here he didn't observe the isotopes. Isotopes are nothing but which is having the same atomic, the elements having the same atomic mass but different atomic number. Means atomic mass is seems to be same. Atomic number as the atomic number are increasing, the mass number also increases, but somewhere in the hydrogen and chlorine they are having the same atomic number but different mass number. So here these three fellows from Mendeleev, Newland and Dobereiner, these three are arranged the elements on the basis of atomic mass only. So when they arrange the atomic mass on the basis of atomic mass, at that time they were not having the idea about isotopes. So after their discovery, we come to know the isotopes. That was the one reason, no doubt, we can't able to neglect that one. But in first PUC, we are not giving that reason. But those which have given the reason in the SSLC, those are right only. But in PUC, we are giving the reason in the different way. That is, after the Mendeleev, another scientist will come. That is Henry Moseley. He is one of the great scientists. What he did is he plot a graph. Those graphs are, this is new is nothing but frequency. The square root of frequency versus atomic mass. Actually, first time look here, don't get confused. Atomic mass graph. So he plotted a graph. Frequency of X-ray. So he would like to see how this graph appears when he plotted atomic mass versus square root of frequency of X-ray rays when it passes through the atomic masses. How as the atomic masses increases, means same the elements he used as the atomic mass increases, the X-ray ray how it passes. He observed that, but he couldn't get a straight line. But it was somewhere it is randomness. Somewhere it's not a linear, it's getting to be a very cross. But how it is, how was it, we are not knowing. But soon after, by taking a graph, square root of frequency versus atomic mass, he took another one. This atomic number. So already we know that is, right now we are using the modern periodic table that is based on atomic number. So what this Henry Moseley did is he plotted a graph. Square root of frequency means X-ray frequency of the X-ray versus atomic number. He plotted two graphs. In one side he taken as atomic number, and other side he taken the frequency of X-ray. When he plotted the graph appears as a linear, means straight line is observed. It means that as the atomic number increases, the frequency is also increases. This increasing atomic number and increasing the frequency, they are very much linear. Linear is nothing but variation is almost in the straight line. Means it is increasing in a systematic manner, in a linear without any curve shape. So it means that he concluded that, so instead of arranging the elements atomic mass, it's better to keep on the basis of atomic number. Why? Because they are appearing the very neat graph, a linear graph for the X-ray frequency. For that reason, he arranged the same element as the Mendeleev arranged, the same thing only, but he arranged the element on the basis of atomic mass. This fellow arranged the elements on the basis of atomic number. This is the two difference. I hope you are able to remember. This is not the new thing, but the main reason on what basis he arranged means the graph plotted frequency. Which frequency? Square root of frequency of X-ray versus atomic number. It is appeared as a straight line, linear structure. For that reason, he took an idea to use the atomic number to arrange the elements. So he succeeded, and right now whichever we are using the modern periodic table, this periodic table is nothing but the table launched by the scientist Henry Moseley. For that reason, we are calling the modern periodic table. Father is Henry Moseley. Henry Moseley is the father of modern periodic table. For 1 mark you may get a question. Henry Moseley will be the answer for father of modern periodic table. I hope you know this much. And one more question you will get. State the modern periodic law. Modern periodic. This is also known of the same thing. In the Mendelian periodic law, we observe that physical and chemical properties are the periodic function of their atomic masses. Why? Because he arranged the elements on the basis of atomic mass. Whereas here, Henry Moseley, his table was modern periodic table. His law, that is called as modern periodic law, the same thing, physical and chemical properties. Modern periodic law states that physical and chemical, both physical and chemical properties of the elements are the periodic function of their atomic number. In the Mendelian we use the word atomic mass. Here we are using the atomic number. That is the only one word difference between modern periodic table, means modern periodic law, and Mendelian periodic law. Are you getting this one? Don't get confused. This is very much important. If they ask answer, probably they will ask you the modern periodic law only. But those are almost similar. So, but keep in your mind, modern periodic law is based on atomic number, means physical and chemical properties of the elements are the periodic function of their atomic number. So, I hope we are shifting our history of modern periodic table to a modern periodic table. I hope up to here you never get any doubts. From here we will move the detailed concept of this chapter. So I hope you have already observed the modern periodic law. So I will try to show you the modern periodic table. So this is the modern periodic table. So in the 10th textbook also it's available. So this modern periodic table, what it explains, it is by observing the modern periodic table, you can able to explain the properties of all the elements. If I said the atomic number, you can able to say where that element is present in the periodic table. Only by seeing the table atomic number, it's possible to say the position of the elements, and by atomic number only you can able to say the properties also. So this chart is not only the arrangement, it also explain the properties, it also explain the similar properties of the elements. So keep in your mind, this is the best representation for the elements to understand the properties of the elements. Can you see here in the modern periodic table? So this is the modern periodic table. In this modern periodic table, you already know this one. This is not the great or new thing. So it's my bonded duty to explain you once again. Look here, in this modern periodic table, we are having two kinds of the arrangement. One is horizontal row. So this is called as horizontal row. So horizontal rows are called as period. How many periods are there? Total 7 periods are there. And vertical columns. So these are called as vertical column. This kind of arrangement is called as vertical column. The vertical columns are called as groups. So totally 18 groups are there. And 7 periods are there. 18 group and 7 periods. Keep in your mind, they will not ask you such questions. But this is a very basic thing to remember. Total groups are 18. Means groups are nothing but these columns are called as groups. Whereas these are called as period. How many periods are there? Total 7 periods are there and 18 groups are there. So one more, the first important thing is in the whole periodic table, the similar properties of the elements appears down the group. Keep in your mind, don't get confused. This is fundamental things, non which I am going to explain. You have to remember, you have to keep in your mind, so that not only in PUC, not only in first PUC, not only in the second PUC, not only in the competitive exams, even in the degree, whenever, wherever you are going to learn, for the main fundamental, simplest question, even though based on 10th, if you are writing some D group exam or any competitive exam, they will arise as the very simple questions based on this periodic table. So to that extent it is important. I saw many of the students will trying to run this classification of element. because this is very basic and fundamental for every, even on the basis of 10th, how you our seniors are applying the competitive exams, at least to write the D group job. If you want to write the D group job, in that also easily you can observe the these questions in the competitive exam. So keep here, look here, down the group, all the elements are having the similar properties. It means the first group elements which are coming, those are having the similar properties. Any other group, if you are looking at the 15th group elements, whichever those are coming in the 15th group, they are having the similar properties. It means the properties of the elements appears similar only in the group wise, not in the period wise. Keep in your mind. This is first thing. And next one is here the periodic classifications. Modern periodic table is mainly classified into S block, P block, D block and F block. So how they are classified? S, P, D, F, I will explain you later. So before that, let me tell you, totally we are having 117 elements. It means that up to 100 means it is discovered element, they are having name. So sometime if you discovered or somebody is discovered, so they are not calling the directly, then they are not giving the name. So initially they are giving the some of the names, because we are already discovered the element more than 100. So more than 100, if another new elements are discovered, at that time we already have some rules to name that element. The name the new element whichever discovered, or even though it is not discovered, we can able to name the elements which is having the atomic number more than 100, means greater than 100 elements, atomic number greater than 100, that can be named on some rules, that is called as IPAC name. But here in this chapter you are having the naming, means nomenclature of the elements which is having the atomic number more than 100. It may be 100, 101, 102, 125, 125, 126, 150, 145, like that. You can able to have the capacity or knowledge to write the name for the atomic number more than 100. So let's begin how to name the elements having the atomic number greater than 100. So look here, nomenclature of elements with atomic number greater than 100. So how it is possible to write the elements name which is having the more than 100? So you have to remember this chart to name the elements having atomic number greater than 100. Look here, I have given the first column is digit 0, 1, 2, 3, 4 up to 9 it is, and the name of this 0. So for the 0 digit we are calling that as nil, N-I-L. Everything it is in a small letter, no letter, means the first letter should not be written in the form of capital. Everything should be small. Here it is. 0 means nil, 1 means UVL. So nil, the abbreviation is nothing but short form. So 0 is nothing but nil. It can be represented as a small letter N. So 1 is nothing but the small letter. First one is U. Second one is pi, B. Third one is tri, means small letter T. Fourth one is quad, not tetra, means as in the organic chemistry we are naming the elements carbon. So on the basis of mono, di, tri, quad, penta, like that. So sometimes we are using the word tetra, but here particularly in the nomenclature we are using for the fourth digit as a quad, not tetra. Keep it in mind. You want to name that as quad. Quad is the first letter is Q, small letter Q. The fifth one is called as penta. Penta means 5, small letter. 6 means hex. The first one letter is H. So 7 is sept. Look here, sometimes we are using the hept. Commonly we are calling the, if the carbon atoms are 7, we are calling that as heptane in the chemical and its carbon and its compound. We have observed that the naming of the carbon atom, if 7s are there, we are calling that there. In organic compound we are using that as hept. But here we are using, for the 7 we are using as a sept, S-E-P-T, sept. For that reason, the small letter is, you have to use small letter S, sept. 8th one is oct. The first letter is O, small O. If nines are called as, can you see it? 9 is not nan. There we are using nan. Here we are using N. E N N. N. So first letter is E. I hope you can able to remember this symbolic representation. So if you very much familiar about this chart, you can able to name elements which are having the atomic mass more than 100. So look here. Definitely it will be answered for 1 mark in the annual exam. For that reason, name the atomic number which is having the atomic name. Name the atom which is having atomic number 101. If they are sequence, look here how we have to say the names. The first digit present in this atomic number is 1011. So 1 is nothing but was, and the UN means, and 0 is nothing but NIL. NIL. Don't write the running handwriting, write it separately. 1 is nothing but what? Again, UN. Can you see here? 1 is nothing but 0 is nothing but nil. Again, 1 is nothing but un. So after writing this, lastly you have to write the ending. The ending should be IUM. 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 For every elements you have to end by this IUM. So I understand. I have not used any capital letter here. Here I have never used any capital letter. Even the abrasive also I use it as a short letter only. But while naming the full name here, An-Nil-An-Yum, at that time you have to use the first digit as a capital letter. An-Nil-An-Yum. But sometimes most of the students will, means even our colleagues also use the word Anilunium. But no need of spelling that one. You just read it as separately, half. Means Anil and Ium. Anil and Ium. Are you getting this one? So here, this is the actually name of the element which is having the atomic number 101, and its IUPAC name is Anil and IUM. Whereas the short form means symbolic representation. Symbolic representation is, while naming the symbol, if you just use the first letter, one is nothing but what? U. This is first letter U, and 0 is nothing but what? Nil, and symbol is N. Again, 1 is nothing but what? And the symbol is U. Are you observing? The symbolic representation is nothing but you have to name the first letter, that is abrasive form of this one. So whenever they are telling you write the name, means don't write directly symbol. You must and should write the IUPAC name, and then you have to write the IUM. Later you have to represent the symbol also. So same thing here also, while writing the symbol you have to use the first letter as capital. First letter as capital. So next one is 112. 112. Write the exact name of atomic number 112. So 1 is nothing but what? An. The first letter you have to use the capital UN. An. So again 1. 1 is nothing but again an. UN. 2 is nothing but what? By. BI. And next one is NIUM. IUM. If the two are there, nothing will happen. Sometimes only one I we are written. If you are written 2 means no problem. And by IUM. So in the abrasive form, symbolically 1 is nothing but U. Again 1 is U. 2 is nothing but B. So first letter it should be the IUUB. Similarly 125. Atomic number 125. 1 is nothing but, and 2 is nothing but by, 5 is nothing but penta, that is P. Pen. Finally, you have to write IUM. Are you getting? This is very easy one. And symbolic representation, 1 is nothing but U, first one. 2 is nothing but B. 5 is nothing but what it is? P. Are you getting this one? The very first letter is capital in naming, but not here. Here everything should be small. Here the first letter only capital. remaining as it is. So take it up homework 129, 140, 128, 142, 104. You take this as a homework. You have to write the iPad and symbolic representation. I hope it will not much difficult for you to write the name, isn't it? If you want, you can take a screenshot and write it thoroughly. Look here. The next one is electronic configuration of elements and the periodic table. So here the whole periodic table is based on the electronic configuration, the whole periodic table. So without electronic configuration, it is not possible to describe or even imagine the periodic table. Means periodic table, every elements it is based on, means how they are arranged. No doubt they are arranged on the basis of properties only, but they are undergo the position of the elements and property. Everything it is totally based on electronic configuration. What is that electronic configuration? So very few those who have completed in the CBSE, they are familiar with the electronic configuration representation. Those who are state syllabus, they are stranger about the electronic configuration. Look here. So first one, in the periodic table, we observe that there are 4 blocks. One is S block, B block, D block and F block. So here the group 1 to 2 are called as S block element, 3 to 12 are called as D block element, and 13 to 18 are called as P block element. And below this group there are 2 rows are arranged, that is lanthanide and actinide. So these two together, these are called as F block element. In the periodic table, S block elements are nothing but first 2 groups are called as S block element. P is nothing but 13 to 18 groups are called as P block element. Group from 3 to 12, those are called as P block element. And F are nothing but lanthanide and actinide, whichever the rows are placed below the periodic table, those are called as F block element. So look here, we have to say that first S, P, D and F. Don't say S, D, E, F, because the elements soon after the element of S, we are going to the P block, and again we are going to D, and later F block. Because of that, we are calling that S, P, D, F. And how we are calling, why only the S, P, D, F? So it will come to know in the next. And one more thing I would like to remind you. So you are familiar about the structure of atom. Center nucleus will be there. That nucleus containing nucleus, neutron and protons. So electrons will be revolving around the nucleus in a definite path. The path is called as shell. It is called as shell, and it is also called as orbital. The first shell is called as K shell, second one is L, next one is M, and next one is M. K, L, M, N are the shell. In this shell, electrons will be revolving, and you are very much familiar up to this. The total number of electrons can be calculated by the formula 2n square. So this all we have discussed thoroughly in the high school level. I hope is it clear for you. But we are not discussing this everything, but you should know this one. So coming to this one, so K shell containing how many electrons totally? 2 electrons. K containing 2, L containing 8, this is 18 and 32 electron based on this formula. I hope you can able to say yes, because in the high school you already studied this concept. But we are not going to explain, and we are not using the concepts here, but we are going this periodic table containing S, P, D and F. Those periodic table can be described on the basis of electronic configuration. What is that electronic configuration? Look here, S, can you see S, P, D and F. So these are the position of the elements. Whereas what is this S, P, D, F is nothing but, you should know, the K shell containing only one subshell. K shell containing the subshells. Most important it is, because this is very much new concept for you people. K shell containing only one subshell, that is small s, small letter s. The next L shell containing two subshells, that is S, P. The third shell K, L, M containing S, P and D. And the last N shell containing S, P, D and F. These are the subshell. If we call this as the orbit, this is orbital. I mean, this is, we are calling that as orbital, and this is orbit. This is orbital. This is the orbit. Commonly we are familiar with shell. These are the subshell. So K shell containing only one subshell, that is S. L containing SP, M containing SP, L containing SP, D and F. So here, this is 1S, this is 2S and 2P. We are moving in the period wise. 1S, 2S, 2P. This is 3S, 3P, 3D. Means first shell containing one shell, second shell containing the 2S, 2P. This is third shell containing 3S, 3P, 3D. And fourth shell containing 4S, 4P, 4D and 4F. If it is continued similarly, it is 5S, 5P, 5D and 5F. Don't try anything extra word, because up to F we have discussed, we are discovered, we didn't discover the further one. So even though next we have written 6S means 6S, 6P, 6D and 6F. इतना ही लिखना तो ये ज़्यादा नहीं जाना चाहिए, क्योंकि ನಾವು ಲಿಮಿಟ್ ಅಷ್ಟು ಡಿಸ್ಕವರ್ ಮಾಡಿಲ್ಲ. ಸೊ ಮುಂದೆ ನಾವು ಡಿಸ್ಕವರ್ ಮಾಡಿಲ್ಲ, ಎಫ್ ಲಾಸ್ಟ್, ಕೀಪ್ ಇನ್ ಯುವರ್ ಮೈಂಡ್. So is it clear for you? So after that, what I am explaining, this is the most important. Look here, correct time observe madre. So here how the electrons fills means, first in the K shell electrons fills 2 electron, and next it will move for the L. After filling the completion of L, it will move for the M. After completely filling the M, it will move for the M. So this is generally we are calling, but actually it is not happening like that. So it is happening how means, look here. So first electrons moves to the first shell, and again look here, I am taking the return, and the electrons are filling the this way. 2s, after 1s it is completing the 2s, and again it is moving up and filling takes place from the up to down. 2s next to 2p, and it is coming to the 3s. After 3s it is again coming from this 3p, 4s, and next it comes from, after 4s 3d, after 3d 4p, after 4p 5s, and again it is coming like this. After 5s 4d, after 4d 5p, after 5p 6s, again it is coming. After 6s the electrons are filling to the 4f. After 4f it fills to the 5d. After 5d it will move to the 6p. After 6p it will move for the 7s. Are you getting this one? How I am writing means, first one I think you observed 1s, 2s, 2p, 3s, 3p, 3d, like this one way. Electrons filling takes place in this route, in this way. 1s, 2s, 2p, 3s. After 3s it seems that the electrons are filling in this way. Actually it's not filling this way, it's moving this. 1s, 2s, after 2p, 3s, after 3p it is not moving to the 3d, after 3p it is moving to the 4s. After filling the 4s it is coming to the filling of 3d. After fully completion of 3d it is moving for 4p and 5s. After filling 5s coming to the 4d, 5p, 6s, again it is coming for 4f, 5d, 6p and 7s, again it is coming for 5f, like this. Why I am telling this? You have to capable to write the electronic configuration only on the basis of this chart. If you can't remember this one means you can't able to write the electronic configuration. If you are not able to write the electronic configuration, you can't able to justify the position of the elements in the periodic table. So must and should you have to practice this chart and you have to remember. I hope you can able to understand. These are the shell, these are the subshell. So SPDF, somewhere you can observe that it seems to be a capital letter. Don't write the capital letter. Everything should be a small letter. Even S should be the small letter. SPDF are small letter. Look here, I will tell you very important concepts here. How many electrons can able to fill it in S? So only S can fill 2 electron, P can fill 6 electron maximum, and in the D we can fill 10 electrons, and in the F we can fill 14 electrons. Keep in your mind, this is the most important. In S maximum 2 electron, in P maximum 6 electron, in D maximum 10 electrons, in F maximum 14 electrons. You can't write exceeds more than 14 or more than 10 here. The minimum you can write one, at least one, or you can say the 0 also, but maximum 2 electron. After filling the electrons in S 2, 1s 2, it will mean for the 2s. In 2s the number of electrons should be 2. So think that if the atomic number, if I say atomic number sodium is having the atomic number 11, if I set the 11, so then how you can write the electronic configuration? Write the electronic configuration for the sodium which is having atomic number 11 means 1s1 first, and next one is 2s. Yes, number of electrons will is 2, and after 2s it will be for the 2p. 2p, how much electrons? 6 electrons. Look here, 1s, 2s, next 2p, again it will move for the 3s, 2. Look here, 1s, 2s, 2p, 3s. Yes, maximum electron is 2 and p maximum electron is 6. Look here 2 electrons, here 2, total it is 4. 4 plus 6 is 10 electrons. After 10 I have written 2, 10 plus 2, 12, but I need only 11 electrons. Therefore I will write 3s1. This is the representation of electronic configuration of the element. Similarly, carbon atomic number 6 means first 1s2, next one is 2s2, 2p, 2 plus 2, 4 electrons. How much I need? 6. Already 4, still I need 2, only 2. So I can write P ka uttar. Next very good maximum I need only 2 here, because to make it as atomic number 6. 2 plus 2, 4, 4 plus 2 need, because to make it as an atomic number 6. This atomic number represents the number of electrons. Total number of electrons should be equal to the atomic number. Can you able to understand this one? So this is the representation of electronic configuration. Keep in your mind at least this one, and from the next class I will tell you how to write the further electronic configuration, and based on this electronic configuration how can you able to explain the elements. So for you, take it as homework. The atomic number 12, 25, 9 and 18. Write the electronic configuration for this element having the atomic number 12, 25, 9 and 18. So this is the homework for you, and keep ready for the homework next time. So I hope you much this much is thorough. So we will continue the same thing on the next class. Have a nice day. Bye.